Now, fixing network problems when they happen is one thing. Heading them off before they even begin is quite another, isn't it? I'm joined now by Passan and Steve. Welcome, first of all. We're looking now at the proactive service assurance via closed-loop predictive AI and machine learning. Passan, tell me more about this challenge and how you're tackling it with this catalyst.
As Sri Lanka Telecom, more than 100-year-old company, we are having a legacy and new devices and new networks. So we are facing very challenging when we are having the troubles in our networks and the alarms and the fiber downs, something like that. So we are struggling around hours, maybe 1 or 2 hours to even find out the root cause. So I joined this Catalyst project to take the challenge of SLT to improve, rectify the problems, reduce minutes. Then that is my aim, and I gave my real-time data to support the project to achieve that target.
And Steve, what have you achieved in this iteration?
So we found that we can actually predict a certain number of events. Obviously, due to the nature of events, you could have somebody dig up a cable or something which is completely unpredictable, but a significant number of the faults are predictable, and we can predict them and we can actually resolve them before they happen.
And what's the business value to this as well then?
So the business value is that the customers, their experience is more positive because they're not actually impacted by a problem. It also means that you're getting less calls to the contact center, so obviously your costs are lower, and things like the Net Promoter Score will actually increase because the network availability and the service quality is positively impacted.
And within the process of getting this catalyst sorted, are you using real data?
Yeah, we are. We got data from both champions, so Sri Lankan Telecom and Do provided us data. So they gave us a huge amount of information that we used, because I think it's important in these kind of scenarios to try and use real data, otherwise it's just all simulated.
And so the question is, what's for the future?
So in the future, we're looking to use additional data sources. So we're going to pull information such as ticketing information. We're also going to use hopefully some really interesting city data to be able to look at traffic accidents and stuff and how they can be brought into this ecosystem.
Steve, thank you very much. Passan, thank you for your time.
Thank you.